Physics Chapter 2, Problem 62. The problem reads, does a real automobile have constant acceleration? Measure data for a Porsche 944 turbo at maximum acceleration are shown in the table. A says convert the velocities to meters per second, then make a graph of velocity versus time. Based on your graph, is the acceleration constant? Explain. B is estimate how far the car traveled in the first 10 seconds, and then C, draw a smooth curve through the points on your graph, then use your graph to estimate the car's acceleration at 2 seconds and 8 seconds. Give your answer in SI units. Hint, remember that acceleration is the slope of the velocity graph. Okay, so for A, we need to convert our miles per hour to meters per second. So to save time, I just converted 1 mile per hour in meters per second, and that comes out to 0.45 meters per second. So we just have to convert all of these into meters per second. So the first one is 41 miles per hour times 0.45 equals 18.5 meters per second. 66 miles per hour times 0.45 meters per second equals 29.7 meters per second. And then 83 miles per hour times 0.45 equals 37.35 meters per second. 97 times 0.45 equals 43.7 meters per second. And then 110 miles per hour times 0.45 equals 49.5 meters per second. So now that we converted all of these, we had to graph them, and I graphed them here. And it's asking us if it is constant, and the acceleration isn't constant because points don't lie on the slope line. So B is asking estimate how far the car traveled in the first 10 seconds. And so we need to find the area of these two. So to find the first area, we just do 18.5 times 2 over 2. Our 2's cancel out and we get 18.5. And to find our second area, we do 18.5 times 8 times 52 minus 18.5 times 8 divided by 2, and that's 282 meters. To find the distance, we need to add both of these areas. So we do 282 plus 18.5, and that should give us 300.5 meters. And so then C, we have to draw a smooth curve through the points on our graph, then use your graph to estimate the car's acceleration at 2 seconds and 8 seconds, and give our answers in SI units. And our accelerations, we just have to do our velocities divided by our times. So the first one would be 18.5 in 2 seconds, and then that gives us 9.25 meters per second squared. And then our second one is our velocity, which is 52 minus 18.5, and divide that by 8 seconds. And then we get 4.19 meters per second squared.